Welcome back to my set of Git video. In continuing the previous video, I want to show you a real better way to work with remote and how two developers can collaborate. So now I'm simulating a couple of developers, one working in a Windows machine and the other working in the Linux machine. As I show you in the previous video, I'm not using any server or anything else than a shared folder. So first of all, I have a repository. The repository is working in a Linux machine. I've pushed on a local folder, share the local folder. Let's see how another developer can work and collaboratively with that repository. First of all, instead of doing as the previous episode where I do git init, git remote add, blah, 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 I can use a new command that's called git clone. And that's the usual command you find. And it's probably the first command a developer knows when you start working with Git, but it's a little bit more complex than you think. So I'm using a git clone and the share folder. And actually that command does a lot of things. First of all, it creates another folder with the same name of the latest part of the remote. So I can go to the git share and I can find that I indeed have an src, a readme markdown. If I really open my code, Visual Studio Code, I can verify that I indeed have a Git folder and have the same content on Linux. That means Git clone does a lot of things for you. It creates a folder, it run git init in that folder, it add a remote, it fetch data from the remote, it find the default branch on the remote that by default is master or main, and it automatically check out the master branch. So you have your working folder with the content of the master. And if you look at the config, you can see that indeed you have a local master branch that is pointing to the remote master branch. Now, let's move on and let's modify the README file. And I add one line, and this is on Windows. Okay, so I'm writing some sort of modification to the file. Okay. So now I can open a terminal and I can say get status where I really find that I have a modified readme file. So I can get add and I can get add, dot get commit -m done in Windows. Okay, now I have another commit in my local Windows machine. Now just go to the Linux machine. The Linux machine contains the very same folder with the very same content. And now let's modify another file so you don't have conflict, okay? So you have another command done in Linux box, okay? So I save, get status, I've modified the file, get commit -a. It is another shortcut to avoid issuing git add dot. So git commit -a tells Git to include all the modified file, not the new one, only the modified file in the next commit, and done in Linux. Okay, now I've done modification into two unrelated files from one developer in Linux and the other developer in Windows. Now, let's see how you can reconcile those modifications between the two developers. First of all, there is no different situation than I show you when I show how to reconcile two local branches. Because if you look at the refs inside the Linux box, you can find this situation. You have one master that is pointing to the B2F, blah, 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 blah. And you have a remote origin master that is basically pointing to another commit. And that's normal because when you commit something in your local branch, what Git does is creating the index, compressing the file, creating the commit, and looking at the head. And the head is pointing to ref as master. So you create a new commit, take the ID, and copy into the local master branch. Okay, so nothing different from what we saw before. Now, let's suppose that the developer in Linux box first want to share this new modification with everyone. So he can simply issue a git push. And okay, it seems everything went well. And now the remote's origin is updated to contain the same content of the local master branch. So when you issue git push, the client does roughly the following operation. First, it checks if the object contains new stuff to be pushed on the remote. So it found that the master has some object need to be pushed, and it pushed to the remote folder. But before doing this, it checked if the master on the remote is still on the old position. So it check if it's trying to do a valid operation or it can modify and delete some code on the other developer. And it will be clear when we move to the other machine where the Windows developer try to push its modification. The Windows developer can now try to issue a git push command as you did in the Linux box, but then you got some error and fail to push some ref, and the remote contains work that you do not have locally. Now, Git is protecting you from overriding the change made by the other developer. If you remember, we just pushed a few seconds ago commits into the remote repository from the Linux machine, and now we need to reconcile those changes. To do this, we usually issue a git pull, but before introducing you to the git pull command, I want you to understand what is really happening. Now I issue a git fetch, and it is indeed getting stuff. So the master branch in the remote's origin appears. So with git fetch, it's the same command I've done in the previous video. It is just taking all the information from the remote and synchronizing the local version. Now what you have is your master point to this commit and the master on the remote point to this other commit. Clearly, these two commits are different, but let's see what's happened graphically. This is what we can see graphically on the local repository in the Windows machine. We have our commit done in Windows, but with fetch, we fetch locally the commit done in Linux. And clearly, the master of the origin is pointing to this new commit done in Linux. Because what happened when the Linux box pushed the modification onto the remote, this commit was pushed and then the master was updated. Now, when you try to push your local modification to the remote, your client stops and prevents you from doing this because you see that there are indeed some commits that are not included in your master. Remember, it is a client protection. If you issue a git push -- force, you will actually override all the modification done in Linux because you can force without any problem pushing this commit into the remote and then forcing the remote to point to this commit, actually overwriting and deleting what was done by the previous developer. So it is a client protection. What Git asks you is to reconcile those modifications. Now, as I told you in the previous video, you have two branches and you need to reconcile modification on those two branches. And the fact that those two branches are contained in, identified by a local branch master and the corresponding remote origin master branch is no different between having a foo and bar master on the local repository. As you can remember, you have two distinct strategies for reconciling those branches. The first one is merge. Merge will create a new commit that reconcile the modification between the remote corresponding tracking branches and the local branches. And as you should remember, it does not create a linear history. So it could probably not be the thing you want. And sadly enough, it's the things that is done by default by the git pull command, because a git pull command is just doing a fetch of the repository and a merge of the local branch with the remote corresponding tracking branches, the upstream branch. This is actually a setting you can verify with git config --list select string rebase in Windows. And I have this option pull rebase equal to true. And that means that when I issue a git pull, I was previously in this dd32178 commit. I fetch the other commit from the remote, and then I rebase my local commits of my branch in the upstream branch. And that's because I'd like to have linear history and not an history where I have merging. Clearly, this is only a matter of preference. So I'm not telling you you must set the pull rebase equal to true. I'm strongly suggesting you to do this because, as you see, when the multiple developers works in their machine, you are actually having one different master branch for each developer. So if 20 developer modify 20 different files and they all issue a git pull without the rebase true, each pull will create a merge commit and the history is becoming a little bit hard to read. So as a general suggestion, when you need to reconcile your local modification, so the modification you've done in the local branch with the remote upstream branch, I usually suggest you use git pull --rebase, or you set the pull rebase to true. But let's for now reset the situation as it were before. So I'm going to reset my master to the previous dd32178 commit. So I can issue git reset --hard, and then I need to specify the commit. As I told you before, you can always reset hard your local branch to point to another commit. So instead of pointing to this commit, that's the result of the rebase, we are in the same situation as we were before issuing a git pull --rebase, or issuing a standard git pull because my pull rebase is equal to true. So to reconcile your local modification, the usual path without having the shortcut of git pull is git fetch. You fetch everything from the remote repository. So if I'm now on the master branch, I can issue a git rebase origin master. So what I'm telling it, I want to rebase my master branch because I'm on the master branch on the corresponding upstream branches, just to incorporate every modification in a linear history. As you can see, I have created my new commit and the history is linear. And yeah, that's the previous rebase commit. If you remember, in the commit, there's a timestamp. So even if I've done the very same operation of rebasing, I cannot create the same commit because the timestamp in the commit file will unless be different. And as a final touch, when everything is okay, if I'm now issuing a git push, everything is okay because Git is verifying the local client is issuing another fetch. It verified that the master correctly point to this B2F4EB3 commit. He understands that the local master is rebased. So there's a path that brings from the origin to the local pointed commits, so it can do a fast forward. So actually it is sending this physical commit to the remote, and then it's simply updating the remote branch to point to this, this commit. Now let's see what happens in Linux. Okay, now in the Linux machine, if I issue git log f, we can see that the master is aligned to the origin master, but now the Linux developer issue a git fetch to grab all the modification from the remote. And if he issue another git log f, he can verify that indeed someone else has done some work and the master origin master is updated. So he can simply git pull -- rebase and incorporate his local modification with the remote one. So this time he or she has no local modification. But the usual path is, before you're going to work on a branch, you usually do a git pull -- rebase and you reincorporate eventual modification present in the upstream branch. Then you work locally. You try to push. If the push failed because someone else in the meanwhile had updated the branch on the remote repository, you can simply issue another git pull -- rebase and reincorporate the modification in your local branch and try again to push until your push succeeds because no one else changed the remote branches between your pull rebase and the push. As a final touch, I can show you that we are in the share git share. So this is the Bay repository. Actually, if I'm in the Bay repository, actually I have a real working Git database, but I have only the master. You are not supposed to work with this repository, but as you can see, this repository, this database is remotely managed by both client, the Linux and the Windows one. So both of those clients simply put file inside the folder, check what's written in the folder, and simply manage remotely this database without needing any server or any other thing. And that's pretty much all for this second video about working collaboratively with Remote and Git. I'm waiting you in the next video.